Welcome back. Today we are going to be going through lesson 11.3, which is probability and statistics having to do with two-way tables. So let's jump in and talk about just what a two-way table is. So a two-way table is a frequency table, which just means it's a table representing some data from a source that belongs to two different categories. So we're collecting data, asking people questions, or collecting data of some sort, and or talking about two different categories within this data. So maybe it's male and female and has a license or doesn't have a driver's license, something like that. So two different categories of information that we're gathering. So when we collect that information in the two different categories, one category is represented by the rows in the table, so going across, and the other is represented by the columns, so going up and down. So we'll see some examples here of some two-way tables in just a second. All right, so there's some key phrases that we need to understand. Joint frequency is just each individual data point in the table. Marginal frequency, so think about the margins of your paper. Marginal frequency is the sum, so where we bring a whole category together. So those are on the outside of the table or the edges of the table. And then we're going to use all this to find some conditional probability. So conditional probability is the probability of event B, whatever that might be happening, given that A has already occurred. So we know one piece of information and we're finding a probability of the next thing happening. All right, so within our table here, let's go back to these joint and marginal frequencies. So in joint frequencies, remember that's each individual data piece. So when I look at my data table here, the one we're going to do, these individual pieces in here would be our joint frequencies. Those are the pieces of data individually collected from each person we're asking or each data point. The ones along the outside, so these totals out here of either the rows or the columns, those are our marginal frequencies up here. So marginal, the margins, they represent the sums on the outside. So we're going to put some information into a two-way table here. So here's what that's going to look like. In our table here, we're looking at the Venn diagram to get our information. We surveyed a total of 89 students here, and we asked them two questions. Do they play a sport? And do they speak a foreign language? So students answered those two questions, and we're putting it together in this table. So when we look at our joint frequencies, so looking at the boxes highlighted in purple here, we're looking for where the students that do both things come together. So in the top left, we have students who play a sport and speak a foreign language. So in this box, we are trying to find the students that do both. They said yes to both questions. So on the Venn diagram, that would be our students in the middle. Okay, so now when we look at the box below that, we're looking at students that speak a foreign language but do not play a sport. So they are only in the speak a foreign language bubble. That would be 26 of them. All right, so then in the right-hand column there, we're looking at students who do not speak a foreign language. In the top box, they don't speak a foreign language, but they do play a sport. So that would be the 37 on the left side of our Venn diagram. And then right below that is the students that don't do either. They don't play sport and they don't speak a foreign language, so they're not within the bubbles of the Venn diagram, and that is the 12 that are outside it. So we use the Venn diagram, our data points, to put people into the joint frequencies. Once we have the joint frequencies, then it's our job to come up with the numbers on the outside or the marginal frequencies. So we're going to add those up. So going across, if I add the 14 and the 37 students that play a sport, I get a total of 51. For the column that do not play the row that do not play a sport, I've got 26 plus 12, which is 38. If I add those together, I get a total of those 89 students, which we can confirm from before. Those are my 89 students that I talked to. Then we're going to add up the columns. So 14 and 26, that's a total of 40. Do not speak a foreign language column, 37 and 12 makes 49. So those are my marginal frequencies. And again, I just double checked those add up to 89. So I've got everybody covered in there. So that's kind of how we create a two-way table from our data points. So we're going to now use that two-way table to help us answer some questions down below. So down below here, it's asking us how many students play a sport. So when we look at our table, we can see play a sport is the entire row across the top, and so that would be 51. That would be our marginal frequency there. For part B, it says how many students speak a foreign language and do not play a sport. So for this one, we're asking where those two things come together. So that would be a joint frequency. If we go to speak a foreign language and then down to do not play a sport, there's 26 students in that category. For part C and D, it's asking us to take those pieces of information and now calculate some probabilities from them. So thinking about probability, we're going to have to do a fraction with what we want out of the total. So what's the probability that a student plays a sport and speaks a foreign language? So when we see plays a sport and speaks a foreign language, they come together. There are 14 of them. Since it's a probability, we want it out of the total. So 14 out of 89, we can leave that as a fraction. We can change it to a decimal, which in this case would be 0.157. Or we can, of course, turn that into a percentage, which is about 15.7%. For part D, it's asking us for another probability. So this notation should look familiar, hopefully. So this is saying, what's the probability that a student does not speak a foreign language, given that, remember that vertical bar, given that they play a sport. So now, this plays a sport is our total that we're looking at. So when we look at those conditional probabilities, we're saying we're only looking at the kids that play a sport. So for this one, our total of plays a sport is out of 51. And then we want to know out of those 51, so looking at only the plays a sport row across the top there, how many do not speak a language? And so in that sports row, the number that do not speak a foreign language is 37. So my probability changes when it's conditional because now it's only out of the students in the one category that we want to have happen. All right, so when we calculate that, 37 out of 51 is about 0.725. So about 72.5% of the students who play a sport don't speak a foreign language. All right, so those are some basics on our two-way tables. What we're going to do next is we are going to create our own two-way table. So for example 2 here, we're going to use some information in the word problem to fill in our table, okay? And you can kind of see down below, there are some steps. So the first one is to organize the data into the two-way table. So we're going to read the question and figure out where things go. So the first thing it says is that a survey was given to juniors and seniors. So I can tell right away that juniors and seniors is one of the categories that I separated my data into. So some students were juniors, some students were seniors. So that's one category. And they were asked whether they have brown eyes. So that's my second category. Some students had brown eyes and other students did not. So we could say they have an other color of eye. So those are my two categories. So as I read through the problem, now I can start to fill in some information based on the numbers that they give me. So they say in this survey, 154 juniors. So I have 154 juniors out here and 196 seniors. So those are my row totals based on what they're telling me. Then they tell us of those 127 juniors and 148 seniors said they have brown eyes. So 127 juniors said they have brown eyes. So if I go up to juniors and brown eyes, I've got 127 in that spot. Same thing for the seniors. Now we've got 148 seniors that have brown eyes. So those come together there. So I have used everything in the word problem that I can use in order to organize my data. So I've got everything out of the word problem into my table. And now I need to fill in the missing pieces. So if we look at step 2, it says to find the joint frequencies. So we're figuring out what's left. So in order to do this, what I'm going to do is I'm going to calculate some joint frequencies here. So what I know is that I have for my juniors, they told me that there are 154 total and that 127 have brown eyes. If I subtract those, so 154 minus 127, I get a total of 27. That's how many were left that didn't have brown eyes. They have another color. So I'm going to do the same thing for my seniors. So if I look at my seniors, I have 196 total. So if I look at my seniors, I have 196 total. 148 had brown eyes. So if I subtract those, I would get 48 that were left with other color eyes. So again, that is my seniors. So I have now calculated in step 2 my remaining joint frequencies that I didn't have from the word problem. Now what I'm going to do for step 3 is I'm going to find my marginal frequencies. So I've already got the marginal frequencies for the rows. Now I'm just going to calculate it for the columns. So in the columns, I'm going to add what I have together. So for my marginals here, in the brown eyes category, I've got 127 and 148. So I'm going to add those together. And when I add those together, I get 275 for the total of brown eyes. And then for other color, I'm going to add 27 and 48 for that row. And in that case, we get just 75. So 75 students had other colored eyes besides brown. And then lastly, of course, we're going to find the sums of those. So for my remaining box, my total of the totals, I'm going to add, you can choose, you can add either the row or the column, doesn't matter. But I'm going to add the 275 plus the 75 students that have other colored eyes together. That makes 350 students. And you can, of course, check your work by adding the columns. We could add 154, 196. That also comes out to 350. So when we're creating the table ourselves, we sometimes have to do some calculations in order to fill in missing pieces that weren't given to us, but you should always have enough information to fill in all the boxes in a two-way table. So now what we're going to do is we are going to use that information to calculate some probabilities down here. So the first thing they ask us is how many juniors do not have brown eyes. So if I look at my table, juniors that have an other colored eye, that would be 27. So there are 27 students who do not have brown eyes. They have an other color. B is asking me how many students do have brown eyes. So if I look at my total for brown eyes, we can see that's 275 students. All right, and then like before, for part C and D, it's asking us what's the probability of some things happening. So C is asking us the probability that a junior and senior have brown eyes. So that's out of everybody, my 350 total students that we talked to. How many have brown eyes? If I scroll back up and look, my brown eyes was 275 out of the 350 total. So if I divide those out, it comes out to about 0.786 or about 78.6% of the students in this survey had brown eyes. For part D, again, it's another conditional probability. So the probability that someone does not have brown eyes, given that they're a senior. So again, when we look at this one, we're looking at just our seniors. So we have 196 seniors. That's my total now, remember? And then out of those 196, how many do not have brown eyes? There are 48 that do not have brown eyes or have other colored eyes. So when I divide those, I get about 0.245, and that comes out to about 24.5% of the seniors don't have brown eyes. Okay, so those are some of the basics. We're going to take it one step further here and do what are called relative frequencies. So all that's changing is that instead of raw numbers, relative frequencies are percentages. Okay, so let's go through some vocab here again. In a joint relative frequency, we've already talked about joint frequency. That's where two categories come together. A joint relative frequency is the values in each category. So those boxes where two categories are coming together, divided by the total number of values. So we're converting it from a raw number of students or whoever answered the question a certain way, and we're converting that into a percentage. The marginal relative frequency is the sum of the joint relative frequencies. So once you calculate the percentages on the inside of the table, we expand out to those margins and we find the sum. So in other words, what percentage in the survey answered a specific way. And then finally, we have conditional relative frequency, which is like conditional probability. It is the ratio, again, ratio just being like a fraction, of a joint relative frequency to the marginal relative frequency. So dividing an inside piece by a total for that row or column. So again, relative frequency just means we're converting from raw data numbers to percentages of the total. All right, so let's go ahead and continue on here. So we know from that very first example we did, and you can flip back to it and look at it if you'd like. We know that in that first example, we asked two questions. Do you play a sport and do you speak a foreign language? And students said yes or no to either. So in that first example, in the category of speaks a foreign language and plays a sport, there were 14 students. To find the joint relative frequency, we divide that by the total number of students asked. So in that survey, there were 89 total students from that Venn diagram. So we divide those two things, that comes out to about 15.7%. So we're just converting the raw 14 students to the percentage of students that answered that way. Same thing for the other ones. So played a sport, does not speak a foreign language. There were 37 out of 89. That is about 41.6%. Does not play a sport, but does speak a foreign language. There were 26 out of 89. Is about 29.2%. And then lastly, students who do not play sport and do not speak a foreign language is 12 out of 89. So that puts us at about 13.5%. So those are our joint relative frequencies. Taking the raw data, converting it into a percentage. From there, we find our marginal relative frequencies by adding columns or the rows. So for plays a sport, if we add up 15.7%, 41.6%, we're at about 57.3% for our marginal relative frequency. Same thing for the do not play as a sport column or row. That would be about 42.7% when I combine the 29.2 and the 13.5. And then lastly, looking at our columns, our speaks a foreign language, adding those up, we are at about 44.9%. And in the do not speak a foreign language, we are at 55.1% when we combine 41.6 with 13.5. Together, those should always add up to 100%. We should account for 100% of our data in those. So we're going to answer a couple questions about that table. The first one says, what percent of students play a sport but do not speak a foreign language? So if we look where play a sport and do not speak a foreign language come together, that's that top right box of our joints. So that would be 41.6%. So the nice thing about these is we've already converted them into percents or probabilities, so we don't have to do a lot of math here. For part B, what's the probability that someone does not play a sport? Does not play a sport, the total there is that 42.7, the marginal. All right. So that kind of explains joint relative frequency and marginal relative frequency. What we're going to do now is we are going to use those same pieces of data, but look at them in terms of conditional relative frequency. So remember that conditional relative frequency is the ratio of a joint relative frequency to a marginal. Okay? Example 4, it says use the survey results in example 1 to make a two-way table that shows the conditional relative frequencies based on the row totals. It's really important that you read the problem for this one, because depending on which one we're going off of, it changes your way you're calculating your conditional relative frequencies. So in this case, we are taking everything based off of those row tables from the previous problem. So the row totals in the previous problem, for plays of sport, the row total was 57.3. So that means that both of these are going to be out of 57.3. And the row total for does not play a sport was 42.7. So we're dividing by the total percentage of the row. From there, we're then going to take our percentage from that spot. So the first one was 15.7% out of 57.3, so that would be about 27.4%. And then for the does not speak a foreign language but does play a sport, there was 41.6%. When we divide those together, we get about 72.6%. So now we're seeing, all right, 72.6% of the kids that play a sport. So that's the condition, only looking at those that play a sport. Now in this bottom row, we're looking at only the students who did not play a sport. So out of those, 29.2% total spoke a foreign language and played a sport. Out of the 42.7 that do not play a sport, that gives us 68.4%. And then does not do either was 13.5% overall. When we take that out of the 42.7% that don't play a sport total, we get to 31.6. Notice in these conditional relative frequencies that we only care about the insides of the box. So we don't do the totals on this one because we're already dividing by a total. So let's answer a couple questions based on that information. So for part A, it says given that they do not play a sport, and that's that key part. Given that they do not play a sport, that's why we divided by the total that don't play a sport. So we're looking only at the bottom row because those are the students that do not play a sport. Given that they don't play a sport, what's the conditional relative frequency that he or she speaks a foreign language? So if we go in that bottom row to speaks a foreign language, we're at 68.4%. And then part B, same idea, just written in a different format. This is the probability that someone does not speak a foreign language given that they play a sport. So remember, we already found out of plays a sport that top row total. Now we just have to figure out which box does not speak a language. So that would be that top right box, which is 72.6. Those are your probabilities within two-way tables. We'll see you next time.